Welcome to Inorganic Chemistry class BSP 1173. So in this chapter, the topic of hydrogen, and for the first part, we will discuss on the introduction and preparation of hydrogen. The atomic number of hydrogen is 1. The atomic mass of hydrogen is 1.00798. The melting point of hydrogen is negative 259 degrees C. The boiling point of hydrogen is negative 253 degrees C, and the density of 0.089 gram per liter. Hydrogen is the most abundant element in the universe. It is estimated that 75% of the matter and 90% of all atoms in the universe consists of hydrogen atom. Hydrogen also is the third most abundant element in Earth's surface after oxygen and silicon. The hydrogen exists in star or sun as fuel for fusion. Whenever two atoms of hydrogen is fused together, it will form helium. The reaction will produce energy and heat as the fuel for the sun. In Earth, hydrogen exists as gas. Hydrogen combines with non-metallic elements to form covalent compounds such as methane, CH4. It's combined with oxygen to form water or exists in another compound such as alcohol or ketone. If we look to the periodic table, hydrogen is located on the top of group 1, but is not attached directly to group 1. However, hydrogen having totally different properties compared to group 1 alkali metals. If we look on the properties, the first ionization energy of hydrogen is 1312 kilojoule per mole compared to lithium, which is only 520 kilojoule per mole. The energy required to eliminate one electron from hydrogen is very far greater compared to another alkali metal element. So for hydrogen, it's having electronic configuration of 1s1. The possibility to donating electron and form H+ is smaller rather than sharing electron and forming covalent bonding. Unlike group 1 elements such as lithium, the tendency of removing electron from the atom is easier to form Li+, for example. However, for hydrogen, the energy required is very much. There are three isotopes of hydrogen. The first one is hydrogen or protium. So for this one, it's having the atomic number of 1 and atomic mass is 1. So for hydrogen, it consists of 1 proton and 1 electron. For deuterium, it's having atomic number of 1 and atomic mass of 2. So in this case, there is additional 1 neutron. And the third one, or the third isotope, is tritium, atomic number of 1 and atomic mass of 3. So for tritium, it consists of 1 proton, 1 electron, and with the presence of 2 neutrons. So all these three isotopes occur naturally. It having the different physical properties. If we can see, the mass different is a lot. It's also occur in diatomic molecule as H2, D2, and T2, or combination of HD, HT, and DT. So for protium, or H1, so the natural abundance is 99.985%. For deuterium, or H2, the natural abundance is 0.0156%. It's very less. And for tritium, the natural abundance is less than 1 in 10 power of 17 atom. It is very less abundancy of tritium. There are several methods to prepare hydrogen. It is including reaction of alkali metals with water, reaction of metals with acids, and electrolysis. For the first reaction of alkali metal with water, alkali metal of lithium, sodium, and potassium react violently with water at the ordinary temperature, yielding hydrogen. Lithium metal in contact with water will produce hydrogen and also lithium hydroxide. Calcium react with water more slowly unless the water is hot, when the action is more vigorous. So calcium in the reaction with water will also produce hydrogen gas and producing calcium hydroxide. So this is an example of metal in water. So it will react violently, producing a bubble of hydrogen gas. In typical experiment at laboratory, we will put the metal with water and we will collect the producing gas to the test tube. So the gas can be confirmed by using the burning split, where the pooping of the gas can be observed. On the second preparation of hydrogen gas by reaction of metals with acid, for example, we are using sulfuric acid or diluted hydrochloric acid is added to granulated zinc. The zinc sulfate or zinc chloride is formed in the solution and the hydrogen that is evolved is collected over water in a trough. So we have the metal, in this case is zinc, reaction with acid, for example zinc with sulfuric acid, it will form zinc sulfate and evolving hydrogen gas. For the second reaction of zinc with hydrochloric acid, zinc chloride will be formed and hydrogen gas is evolved. Similarly with the first method, in the Erlenmeyer flask, we have the metal, reaction with acid, so the gas will evolve. So it can be collected into a tube. So the tube that contains hydrogen gas can be tested using burning split. The third preparation method of hydrogen gas in this discussion is electrolysis. Electrolysis is a process utilizing electrical current to separate water into hydrogen and oxygen. So typically, there is a battery or power supply. The battery in this case is connected to the graphite carbon electrode. So individually, it will have the cathode and anode terminal. So in cathode, where the reduction occur, reduction meaning that there is a gaining of electron. So here, water by gaining of electron, it will produce hydrogen and 2 hydroxyl ion. So the water will be generated at cathode, whereas at anode, where the oxidation reaction occur, the hydroxyl ion will transform or the reaction will produce oxygen, water and 2 electron. So the overall reaction here, we can subtract this one, the electron, and there is remaining of 1 water, hydrogen and oxygen. So the overall reaction of electrolysis is 2H2O will produce 2 mole of hydrogen and 1 mole of oxygen. The properties of hydrogen gas, it is colorless, odorless, less dense than air, and it is not dissolved in water. That's why in the preparation of hydrogen gas, we can collect the hydrogen gas through water.